This is a brief overview of photosynthesis, which happens in autotrophs such as plants, algae, and cyanobacteria. So first we start with some sunlight. The sunlight comes down here into what we call the thylakoids here, which are these rings, and they absorb the light. And then we're also going to get some H2O. It's going to come into this so that the light reactions can go through. Now they're going to produce ADP and NADPH, as well as a product or waste product of oxygen down here. Now the next step after the light reactions in photosynthesis is the Calvin cycle, which requires the ADP and the NADHP. So you're going to come into here, both come into here, and then three carbon dioxide are going to come, and then that's going to come from, I guess I drew up there, but we can have it down here for now, and then plus 5, what we call Ruby P. They're going to combine for the Calvin cycle, which is going to go around, and it's going to go around twice, and in the end, it's going to we're going to get glucose, which is then going to be sent for glycolysis later on to produce some more energy. Now the waste products of the Calvin cycle are going to be NADP and ADP, which is going to pick up the phosphate eventually. And the cool thing about photosynthesis is the cycle just keeps going on, so the NADPH and the ADP are actually going to come back down for the light reaction and help that out.
Alright, so Luke did a nice job giving us the overview, but to go in a little more detail about the light reactions, we have this here. So the sun has its photons that come down. And the photons come down and they excite an electron. Now the electron is then passed along to the electron transport chain here. So it goes through, and the energy from the electron is used to pump H plus ions that are from the breakdown of H2O through to make an H plus, to make a concentration gradient. The oxygen ions are then released into the air as a waste product. And then you have an excess amount of hydrogen over here. Naturally, the hydrogen wants to get back through, so it goes through here to the ATP synthase, and the ATP synthase converts ADP with P to make ATP and creates NADPH. Next, these are used in the Calvin cycle. For the Calvin cycle, 3 CO2, which is taken in from the environment using stomata, combined with 5 Ruby P, which is a 5-carbon sugar. Those two go through the Calvin cycle through several steps, through which 9 ATP is used and 6 NADPH is used. At the end of the cycle, they produce 1 G3P. However, it takes 2 G3P to produce 1 glucose molecule, so the cycle has to happen twice to produce 1 glucose molecule. As Luke said before, the glucose can then be used for glycolysis, for cellular respiration, or it can be used to create structure in the plant. DNP is a commonly used weight loss pill.
If taken correctly, it can really help you slim down.
However, when taken incorrectly, it can have some serious side effects.
It can have side effects such as shortness of breath, fatigue, or hyperthermia.
Hyperthermia is when the body temperature rises so much that the body can no longer maintain homeostasis.
This can be extremely harmful to the body and even cause death.
Alright, so this here is your normal electron transport chain. As you can see, the NADH and the FADH2 come in, and they are reduced to NAD plus and FADH. Their electrons go through the electron transport chain, and the energy from the electrons is used by these proteins to pump H plus ions through to here. This concentration gradient, naturally with the concentration gradient, the H plus ions want to get down here. But the only way to get through is through this ATP synthase. The ATP synthase is able to harness the energy to create ATP. The electrons here, once the energy has been used, are then go to oxygen, which is oxidized by electrons, and they are canceled away. However, DNP, when brought into the equation, changes everything.
I'm going to tell you about that.
That's right.
Thanks, Vern. DNP, as we talked about before, it's going to come in. Now, DNP is a weak acid, making it soluble in the phospholipid bilayer, which allows it to get across the membrane in there. Now, it's going to take these hydrogen ions from up here, so we have more up here, less down here, which is causing the concentration gradient. It's going to eliminate these, bring them down across here, and now we're going to have them down here. So now, without this concentration gradient, because there's even on both sides, ATP synthase is not going to be able to function. Without the function of that, they're not going to be able to harness ATP, which is going to reduce energy and lead to fatigue.
Yeah, so since it can't harness energy, it can't produce ATP, which obviously would produce fatigue because your body can't function. But your body wants more ATP, so it's going to try and pump more H ions because it doesn't know what this foreign substance is doing. So it's like, all right, we need to get as much up here as possible. So you start pumping in all these electrons, and you get more and more electrons coming through as these proteins try and catch up. So you're pumping more and more H plus ions back up here, and your body's like trying to catch up. However, as Luke said before, the DNP immediately will just cancel that out. So as soon as you have them back, they're immediately brought back across the membrane by DNP, which reduces the concentration gradient. Now, you're producing all these electrons, and so they need to be received by the oxygen. That's why you get shortness of breath. The oxygen you need to receive the excessive amount. As more and more come in, the more oxygen you need. Is also, when your electrons are going through, because you're not producing ATP, you need to produce energy in another form. So the energy is released as heat. That heat energy is what causes you to overheat and causes
sweat.
That's right. It causes you to sweat, and you can even become dizzy.
About that sweat.
Once you start to sweat, that's when homeostasis starts to occur. However, if you take way too much DNP, you can see why it can become fatal, because you become so fatigued and so overheated that hyperthermia occurs, and then it can become fatal or cause serious damage to the body.
Now, I'm also going to tell you about another thing. Heavy breathing. Heavy breathing can absolutely come from DNP. You're trying to lose those pounds? Get ready to breathe heavy. There's a attraction between oxygen and the electrons. Tell them, Vern.
Alright, so the electrons, as I said before, come through, they oxidize the O2, and that's why you need so much air. That's why you need to breathe in more oxygen.
It's gonna get heavy breathing. Just want to let you know, this is DNP.
That's what happens.
Bingo. Alright, listen up. This is why you lose weight right here. We're gonna break down, wrap it up.
Alright, so this is what happens when DNP is used correctly. Alright, so Luke just had pork for dinner, but he wants to lose a few pounds, as you can see.
Mm-hmm.
So he just took a little bit of DNP. Yeah, go ahead.
Okay, so I ate that pork. So be it. Pork goes through my body, goes through the Krebs cycle and glycolysis. It's trying to produce some energy. Well, that pork got turned into NADH and FADH2.
Alright, so now you've got these guys. They, as we said before, are reduced. Electrons go through. Energy from them used by these guys, by these proteins to pump H plus through, create concentration gradient.
But, as like Brett said, I took some DNP. So whatever, no shame. But no more concentration gradient, like we explained before. Thing is, I did not take an excessive amount of DNP, just a little bit.
Yeah, since he only took a little bit, it doesn't completely cancel out the concentration gradient. It just takes it down a little bit. Therefore, the ATP synthase harnesses a little bit less energy and can't produce quite as much ATP as it normally would.
If it can't produce enough ATP, then it's going to be burning more food in the body.
Because you're burning more food to produce enough ATP for your body, that means you're going to store less food in the form of fat. This is how someone who's trying to lose weight would lose weight, because they'd be burning more food and storing less fat.
Less fat.
Dressed up, putting on that lipstick, shimmy shaking right into them cutoffs, baby, oh yeah. You're getting off work, cashing out that paycheck, gotta change that shirt and pick that girl up on her front step. Here she comes now, looking so fine, you've been